Welcome to week 5 of data structures, where we'll be working with hash tables. And in this program, we're going to just create a basic user interface, or GUI, that will allow the user to input a integer value and a string value, which will be stored in the hash table, and the user will have unlimited amounts of entries that if they would choose to, but they will also have the ability to retrieve and see what is in the hash table. They will be able to remove any value that they've entered into the hash table or is already in the hash table, and they can see by showing the current number of elements in the hash table. And finally, we'll be able to run a performance test and compare with the unordered map of what we have entered into our hash table. So let's get started and see what our user interface looks like. Make this a little bit bigger. Hopefully that doesn't go away, but as we can see, we're welcomed into a custom hash table program. This program uses a templated hash table with separate chaining. In this program, you can insert, retrieve, or remove keys or values, and you can also run performance tests to compare the table against the built-in standard unordered map. So let's go with option 1 and insert some keys. So if we choose option 1, we get to insert an integer key. We'll choose 3, and our string value, we could just call it data. And we have inserted 3 data into the hash table. Let's insert another value. So we'll go to 1 again, enter an integer key, choose 7, enter a string value. We'll just say string. So we inserted 7 and string into the hash table. Well, let's see what is in the hash table. We can go to option 2 and retrieve a value by a key. Enter the key we want to retrieve. Well, let's see what was in key 3. The value for key 3 is data, which we entered earlier. So we can see that. If we want to show, I should have ordered this better, but I didn't. I should have put remove after show. But show, let's do a show and see what is in the number of elements. So if we choose 4, the hash table currently contains 2 elements. And if we wanted to then remove a key by option 3, we can choose to enter the key we want to remove. Again, let's remove data, or key 3, which should be data. And we entered the key we wanted to remove, and key 3 was successfully removed. So let's go back to show again and see if now the table only has 1 element. So the 2 elements that we entered, we did remove the 1 element in key 3. And finally, to show the performance element, we choose option 5. And our performance test is completed. And if we scroll up a little bit, we see that our performance test is running. And I changed my timing for my computer since it is fast, and I did nanoseconds instead of milliseconds. And we see all of our actions. We see the custom hash table, the separate chaining and the insert time, the retrieve time, and the remove time. And that is compared to the unordered map. Again, all in nanoseconds. And that was for the first 100 operations. And we will increase our data by going to 1,000, 10,000, and did 100,000 not get in there? I guess 100,000 did not get in there. 100,000 should be in there. But we do get up to 10,000, and we do see quite an increase in our time. That is 2.7, and that is 224. So quite a significant time difference in inserting from 1,000 to 10,000, and then again 224 to 25, call it 26 for 100. So we're seeing quite a drastic increase, and I will be plotting this into a chart with these numbers, and we will see what kind of data that provides, and see how our algorithm works out for this particular program. And all we have left to do now on our GUI is press 6 to exit, and our program closes. And that is my custom hash table insert, retrieve, deletion, and a little bit of GUI in there as well with our testing.